Any weapon built specifically to exploit the peninsula's terrain would have an edge. So, when South Korea produced its first domestically designed tank, Seoul took the mountainous terrain into full account. South Korea started to think about modern main battle tanks in the late 70s when North Korea began fielding T-62s with 115mm guns outmatching Seoul's M48 Patons and their 90mm guns. Thus, the United States gave South Korea permission to domestically assemble a modified Abrams tank termed the K-1. The K-1, like the original Abrams, first sported a 105mm gun. However, the K-1 is smaller than the Abrams and it has a diesel rather than a gas turbine engine. The K-1 also has an uncanny, superficial resemblance to the larger American tank, so much so that US troops stationed in Korea nicknamed it the Baby Abrams. But South Korea owns very little of the technology behind the K-1. 80% of the components came from other countries, chiefly the United States. So while the K-1, which is still in service, outclasses anything the North Koreans have, South Korea wanted a new, domestically designed tank that would surpass any foreseeable North Korean threat. Furthermore, the South Koreans wanted to own all the technology so they could export it. The result was the K-2 Black Panther. Development started in 1995 and cost $260 million. In the end, South Korea designed a tank that on paper appears to be at equal, if not better than, the specifications of current NATO tanks. To achieve this, the Koreans looked all over the world for inspiration, technology and know-how and combined it all into a formidable machine that is distinctively Korean. From Germany, South Korea developed its own version of the Rheinmetall 120mm L-55 gun, which is a full 1.3 meters longer than the 120mm L-44 caliber gun used on all Abrams tanks and older Leopard 2. With a longer gun comes greater internal pressure, so the L-55 gun has superior muzzle velocity. From France, South Korea adopted its own version of the Leclerc's autoloader. Shells are loaded from the back of the turret, via a machine gun-like belt, allowing it to fire 15 rounds a minute if rounds are continuously fired and not accounting for target acquisition, reacquisition and lasing. The tank's fire control system is a technology transfer from France's Thalys, so it is likely again using some Leclerc technology. As an advanced fire control system it is highly automated so even Korea's conscript crews can learn it quickly. Once a target is acquired, the gun and turret can automatically track it without further human intervention. The K-2 can also forge rivers up to 4.2 meters deep via a snorkel kit that doubles as a conning tower, something the Korean Army learned from the 35 T-80Us it acquired from Russia back in the late 90s. Although the heart of a tank is its gun, the next most important component is its engine and transmission, collectively known as the power pack. For this, South Korea again looked to Germany and its excellent MTU 890 V12 diesel 1500 horsepower engine. The domestically designed engine has slightly worse acceleration versus the MTU 0 to 32 km per hour at nearly 8 seconds, up from 7 seconds. The first 100 K-2 produced will have MTU engines and successive batches will sport Korean engines. Yet, despite the foreign influences, there are some original native innovations. The most noticeable is the tank's hydro-pneumatic suspension. Originally developed on the K-1, an improved version allows the K-2 to lower or raise its profile. Like a low-riding street car it can kneel, sit or lean in any direction. This allows the tank to conceal itself using the ultimate hull down positions, the holy grail of defensive tank tactics, where the tank's turret and cannon peeks out from behind elevated terrain which hides most of the tank from any enemies advancing against it. Next is the use of a millimeter band radar in conjunction with the K2's fire control system. Although South Korea didn't invent millimeter band radar, its integration and application of it is unique. Since mountainous terrain is uneven terrain, there is a danger of sudden bumps knocking out the aim of even a stabilized gun while the tank is on the move. The radar predicts uneven terrain and slightly delays the trigger. When the gun realigns with the target, it fires. In terms of armaments, the Black Panther has a range of standard heat and tungsten core sabot rounds, but in addition it has a unique round all its own. With lots of hills there are lots of little valleys for enemy tanks to hide in. When the K2 uses its suspension to sit, it can elevate its gun to a near mortar-like angle to indirectly fire a millimeter band radar guided top attack round. Once fired, the round deploys a parachute, selects a target and shoots a molten projectile into the thin top of an enemy vehicle. Germany and Israel have similar rounds, but only for artillery because their tank guns cannot reach the necessary elevation angle. Called the Korean Smart Top Attack Munition, or KSTAM, it can reach out and touch someone 8 kilometers away. In terms of armor, the K2 most likely has a classified composite blend. Clearly, that doesn't say much, but we do know that the front has been tested to withstand a close-range sabot shot from the K2's own L-55 high-velocity gun. At only 55 tons, the tank is a full 10 tons lighter than the M1A2 or Leopard 2A6. There has been one taker. In 2008, Turkey evaluated this tank against the Leopard 2 and Leclerc. Part of the consideration was that Turkey wanted technology transfers so it could build its own variant. The performance levels were clearly close enough and South Korea sufficiently pliable with technology transfers that Turkey chose the K2 to be the technological basis of its Altay tank project. For around $300 million, Seoul transferred technology, sample components and tooling to Ankara. Faced with unique threats and a terrain that is not exactly tank-friendly, South Korea adapted technology from all over the world, as well as its own innovations, to create a weapon customized to its unique needs and environment.